Hey everybody, welcome back to the show. Shawn Tierney here from Insights in Automation, and we have a special show for you today. I have Michael here from Wieland, and we're going to talk safety PLCs and all kinds of great stuff. But before we jump into that, I haven't had Wieland on the show before. So Michael, I'm hoping you can give us, well, not only introduce yourself, I got to meet him this morning before we started recording, but if you could introduce yourself and then maybe tell us a little bit about your company, and then we can jump into why we're here to talk about these good-looking products. So let me turn it over to you.
Okay, great. Well, thank you, Shawn. Thank you for having me. I appreciate that. And yeah, my name is Mike Warren. I'm a business development manager for Wieland Electric, North America. I've been with Wieland a couple years now, but I got over 20 years of experience in the industry. I have a couple of TUV certifications under my belt. I have a TUV Functional Safety Engineer and also TUV Certified Functional Safety Expert. In addition to that, I do consulting for safety applications. I teach safety classes. I also teach the CFSE class. And I do things like I review machine safeguarding, standards, CE marking, risk assessments, remediations, lockout, tagout, basically everything that is involved in the safety world. These are some of the classes that I cover. So what we're doing today, Shawn, is to talk about our product, okay, the Samos Pro Compact. And the Samos Pro Compact is a safety PLC. It's known by various names, safety controller, brick PLC, whatnot, but it is a compact, as the name implies, safety controller. And in a safety chain, it really is the keystone to a safety system. There's always an input device. Okay, we follow the ILO system, okay? I for input devices, L for logic, in this case, the Samos Pro Compact. And in output devices could be contactors, which I have here in the demo itself, okay? It could be a OSSD inputs from a VFD or robots, okay? So those qualify as output devices. But the input device is for detection, the logic device makes a decision, and the output device executes. And the primary purpose of an output device is to remove energy in an emergency or an intrusion situation. So let's take a look at the product itself. Okay, the Samos Pro Compact, again, is occupying this spot right here in the demo itself. It's 45 millimeters, okay, very compact. The base system is set up with 20 inputs, okay, 20 devices, okay, 20 inputs, it would be 10 safety devices. Safety devices are always redundant. There's 2 points per safety device. So that device is already set up for 10. There's 4 safety outputs on it. And the version that I have here in the demo is actually an uprated version, including motion. So not only will it set up and accept the inputs from some of these safety devices that I have here, for example, like light curtains, I have door switches, I have an e-stop, I also have an analog position switch right there that'll detect the input. Other than those devices, I also have a safety encoder attached to one of the axes in the demo to do motion detection. Not only are we detecting people, but we're also detecting shaft movements. Okay, with the encoder itself.
And that's optional. So there's 2 models, one with motion and one without.
That's absolutely right.
All right.
And I want to point out that the software is free. It can be downloaded easily. You can throw it on your laptop. And the nice thing about it, and we'll get to the software, we're going to show a little bit about it, that you can use the software without any hardware attached to it yet. Okay,
Nice.
You literally can build your safety system in the virtual sense, test it out, check to see if it's working properly. And again, when we dive into the software, you'll see a little bit the nice additional features you get, things like a schematic and the report, and also show you the modules that are actually part of the system itself. Okay. Now, we talked about the communications on this too, okay? We have 3 onboard communication protocols, okay? Onboard, we can work with Profinet, Ethernet IP, and Modbus TCP.
Oh, nice.
There are additional gateways that you can get to add additional comms, okay? That includes CAN Open, Profibus, and EtherCAT. So again, we have a nice way of communicating with other protocols, and let's face it, other manufacturers. And in the safety world, the manufacturers' controllers, the actual automation controllers, are not to dictate to the safety system when to remove energy or not. It's the other way around. The safety always has a precedence and a priority over the controls. Its purpose with these communication gateways is to inform the control systems of what's going on in the safety.
Yeah, I mean, most of the time your master PLC is going to already have an HMI or SCADA system.
Correct.
So they're going to want to display that information. So if you have those, especially the three you have built in, probably the biggest three,
Yep.
According to all the surveys and industry reports and whatnot, having those built in means, I mean, you cover most PLCs, standard PLCs, you're going to be able to give the data to them. They're going to be able to know in their program, they're going to be able to let their operators know using the existing equipment. So very cool.
Yeah, and in this world, we fully understand that it's a mix and match. Okay, rare do we find customers that are using a single brand for everything. It's necessary that one brand of light curtains works with the controller, and another brand of door switch and whatnot. They're all kind of compatible, and the communications though is very, very important because again, they're not operating independently and in a silo.
So if I understand that correctly, so we're seeing your products here, and I really don't know much about your company and what products they make, but I can see you make a lot of products here. So you're saying that you don't just work with the Wieland products, you work with other people's safety products as well.
Absolutely.
So third-party light curtain, or third-party contactor, or safety contactor, or third-party safety push button.
Absolutely.
Okay.
Wieland itself is it's a German company. Okay. They're famous for their terminal blocks. Okay. That's really what put them on the map, many years ago. But there's two pillars for the company right now. One is safety products and the other is distributed power. And again, this is an important product for it. This is really our keystone and our leading product as a logic device in a safety system. So a lot of time and energy and development has been put into this to make it world-class and leading with all the features, like you said, including communications.
Well, I think too, the fact that the audience can go out there and grab a copy of the software and actually simulate their system, that gives them because maybe they're like me, maybe they haven't used your system before. So they can actually build a system, put it together, test it in the simulator without spending a dime. They'll be like, and hey, they go to the boss and say, hey, I got a proof of concept here. Let's call Mike and say, we can't come out and show us more.
Yeah, no, it's a please call. By the way, appreciate that. No, like I say, it is a wonderful benefit. It helps people try to determine because let's face it, not everybody knows and understands safety. Unless you do this day in and day out, you're not up with the latest standards. You don't understand simple things like an e-stop here requires a contrasting yellow background to it. Something as simple as that. Again, the software itself is smart enough where you put these devices together, and if you configure it wrong, it bounces you out. And the reason that it bounces you out or says that you can't, you're not permitted to do that because it's always traceable back to standards. Okay, so the standards are embedded in the configuration, and the algorithms that allow you to drag and drop and put particular devices together are based on the standards themselves. Okay, so the controller itself in a safety system is of the highest rating. Okay, in the PL system, it's PLE. Okay, that is the highest that you can arrive to in the PL system. It's PLE, SIL 3, or CAT 4. Okay, they're all being used in today's industry. People communicate about safety either in CATs or SILs or PLs. But the latest and greatest and going forward really is the performance level, PLE. That's the highest level. But again, it follows basic safety fundamentals that if you attach devices in a chain, a safety chain, and you have PLE, and you have one device that's PLD or PLC, for example, a little lower, then the whole system always reverts down to the lowest in the chain. It's the weakest link, basically.
The weakest link, yeah.
Okay. Again, you're starting out with a PLE safety controller, and now the weakest link is not the controller. It tends to be something else.
Good.
Okay. I mentioned also that the motion control, okay, it has a safe motion embedded in the software, and we're going to take a peek at these a little bit. 6 different TUV function blocks, okay, certified function blocks, okay. They are safe standstill motion, okay, or basically a 0 RPM determination, okay. And all of these function blocks in the motion world are designed to detect shaft motion, shaft speed, shaft position, okay, and shaft direction. All the rest of the safety devices we have on here are for human detection, okay? Hands, like light curtains, hands going in, door switches, gates opening, things like that. To your point, Shawn, that you say, we have compatibility with lots of other brands and lots of other products. We don't have all the safety products that are available here in front of us. For example, safety mats. Okay.
Oh, okay. Yeah.
Safety mats can be fed into this. Okay. It's just another input device. Okay. Safety scanners can be fed into this. Okay. The form factor of a safety scanner is a little different than light curtains. Okay. But it's basic, same principle. Okay. Roll pulley stops. Okay. Two-hand controls. All of these different devices are available in the library, okay? And again, we're going to show the software here in a little bit, and you can configure it as you please with whatever brand you'd like to use. And again, some people are stuck on certain technologies. For example, safety mats are kind of older technology, but they're still viable and a viable solution in a lot of applications, and we see them all the time. So obviously, the safety controller will take those as a viable input.
Yeah, a lot of times I've seen that the choice there is really, I mean, I think most people want to do the light curtains, but I think the mats, the rope pulls, the scanners, I mean, they all address applications where the light curtain just isn't the best fit. So it really comes back, and you tell me if I'm wrong, but it seems the choice there a lot of times comes back to, not always. I mean, there is preferences there when they all will work, right?
Yep.
But the scanners are usually being the most expensive in my experience. But yeah, a lot of it, there are some applications you just have to have the rope pull. Something else won't work.
Yep.
So,
No, you're absolutely right. The application typically drives the choice of devices. And one of the things that I go through when I do safety machine safeguarding classes is this should always be based on risk assessments, really looking at it holistically, the whole system, the usage, the severity of the potential injuries, the frequency, the chances of these injuries type of happen. And again, we put the best recommendations going forward based on what we see applications, but it is by application by application. Rarely do we see two that are exactly the same.
yeah, and the risk assessment, I mean, if you're an expert, you have the training he has, you maybe you can do your own, but a lot of us don't have that training. And so to pick the right products, you got to know what the risks are. And you don't want to spend thousands and thousands of dollars on something and then find out, oh, like the biggest risk you didn't address because it just didn't come to mind. So the risk assessment by an expert is so huge in these type of applications. Again, some of the people, maybe they went to your training, maybe they get certified and they can do their own, but that's usually a big part of a project.
It is, and it's important again to have at least some background. Okay, it isn't really an arbitrary choice of devices. It's usually a thoughtful process, thinking of the input devices and the risks to people, and considering the collaboration of people and machinery together. This is where we have to try to protect humans near the equipment.
Yeah, absolutely, and it's gone out of the days from 100 years ago where you can take those risks. I know a lot of people still do, but every time somebody gets hurt and there's a new light curtain going up or a new guard going on something, the gone are the days where a sign says, don't touch or you may die. That's not sufficient these days. And a lot of that's driven by the insurance companies because they don't want to have to pay out for people getting all these injuries, right? And I think we all know people who are missing hands and thumbs and body parts because they got stuck in a machine. So I think this is a good trend. And these products, I think when you guys see the software, they're super easy to use as well. So it makes a lot of sense.
Yeah. And let's not forget, you mentioned insurance companies, but let's not forget government oversight. Okay. OSHA is here in the United States is really the watchdog for safety. And not only are there costs involved with machine downtime and injuries and insurance payouts, but let's not forget fines levied by OSHA. Okay, and unfortunately, once you get into OSHA's radar, they tend to keep an eye on you, and again, it's this kind of scrutiny you really don't want. Poor publicity, downtime, and again, that's reputation. I mean, at some point, it boils down to company reputation. Okay, but speaking of software, why don't we take a peek at the software here, and let me show you a couple of details about it. Okay, this is the basic work screen right here. I have the software called up. Again, it was a free download. I downloaded it online. And again, I want to create a basic system, okay? I'm not going to replicate this whole system here. There's a lot of devices here, and there could be conditions where I have multiple safety zones, which is something that you can put in the software. But I'm just going to do a very basic configuration. I call it the 5 minutes to safety setup. And what's the simplest safety device to wire up and set up here is the Lonely e-stop, okay? What we're going to do is we're going to take an e-stop, put it into our workspace here and wire it up, run it, make sure it operates properly. I have the proper wiring, I have proper configuration, and then we'll see how the software guides us to that completion, okay? So, Shawn, we're going to grab a device here, okay? I'm going to go ahead and grab an e-stop, and you'll notice here I have a choice, either a single channel or a dual channel. We always want to pick dual channel. Safety is always redundant, 2 contacts per, okay? So I grab that, okay? Now, as part of a safety system, once I initiate an emergency stop, I have to be able to reset it, okay? That's an important part of the actuation of the e-stop. So what I'm going to do is I'm going to grab a reset button, okay? Right out of the library. I'm going to pop it right over here. Now, the next thing I want to do is I have to have the actual contact, the actual initiation of a switch itself, okay? So I'm going to come over here to the switch and I'm going to grab a dual channel switch, just drag it over here, okay? So I have my emergency stop, I have my reset, and then I have the actual switch, the initiation switch of the system. And what's missing? My output device, right? So I'm going to come over here and I'm going to just grab some contactors, okay? Quite similar to what I have in the demo itself. And again, dual channel. I'm going to grab that guy right there, okay? So input device, the logic device is the Samos controller here, and also the software called Samos Plan is right in front of us. Now we connect. I'm connecting here to there. I connect here to here, and then I connect the output to the contactors. Okay? Boom. I'm all set up. That's it. Now, why don't we run and initiate a safety function here? Let's test it out. That's how you're going to really know now, right? I turn the simulation on. The background goes green, so I'm in a simulated mode. I'm in a virtual system right now. And as you can see, I have no hardware set up. I'm just using the software and the tools in the software itself. Okay? I'm going to start the safety. Okay? Start the simulation. You can see the counter go up. This is the time, okay, that I'm actually running the simulation, and I have to turn things on, right? I have to initiate them. Okay? I turn that on. You'll notice here I have this flashing display reset request. I turn that one on, and then I actually do a reset. It's as though I just set up an e-stop and I say, okay, let's initiate it. Let's get it started. Okay? Now, I want you to notice the lines, right? From my e-stop to the reset to the contactors are all green. That means I'm up and live and I have a living, breathing safety system right now. So, how do I know if it's working properly? Well, let's just trip the e-stop. It would be as simple as hitting the mushroom here and depressing it down. Since we're virtual here, I'm going to hit the e-stop right here. My green lines disappear, okay? I've effectively executed a safety function. I pushed the e-stop here, and I lost my connection to my contactor. I now have removed energy from that contactor, okay? And now if I want to go through a reset sequence, I go back on. You'll see the flashing light. I turn that on, and now I have my system back up again, okay? Very easy. And again, I tell people that this isn't really a programming system. This is really a configuration, and you're just dragging and dropping. Now, let's take a look at some of the other tools that we have here. I'm just going to pause the simulation for a second here. Okay, once I actually do this, and I know I have a living, breathing simulation system, okay, I shut off the simulation for a second, and let's see what the software has shown us or what done for us, okay? Number one, the module. It actually shows us the module that it's selected to accomplish the function that we want it to do, okay? This particular model, okay, the non-motion one, you mentioned that before. This is a non-motion because all we're doing is an e-stop detection here. And if you take a look, you'll see some very interesting points, okay? Notice you're going to see an e-stop symbol right here on I1 and I2. It automatically selected I1 and I2 to do that connection. The switch, the reset switch itself, I3 and I4. And on the output side, I have Q1 and Q2. They're my contactors. It actually shows up right on here. Okay? And as you can see on the demo itself, we have lights that are on. We have a communication light on the Ethernet IP port that's flashing. These would be your indicators on here, telling you the condition, whether you have good communications, you have good connections, or in the event that you have a safety trip, okay, some of these indicators will go red. And that's how your first visual, when you approach a controller like this and you see that you have a safety trip, you would have the red indication on here. Okay, so that's the module that came up automatically in the software. Next is the report. Okay, it's going to generate a report on our configuration. Okay, and it's nice because there's a lot in the report itself. If we scroll down, we end up with a CRC control number. This is actually a time date stamp that identifies the unique configuration of the project that we just created here based on the time date, and it's unique. Okay, and when you go ahead and build a big system and you get a machine commissioned, okay, the CRC number is important to identify the material condition and the safety, the report that is generated, the safety level, and it'll be identified here in the report itself. Okay, list of materials. Okay, we have not only a bill of materials. Okay, scroll down. There's our controller again. That is in the report. Again, it's a replication of what we saw in the software. There's a bill of materials, the actual devices that are part of the safety system here. Okay, and we scroll down a little bit more. If we ran some diagnostics and more elaborate systems, we can run diagnostics and collect that information and actually have it show up here in the report. Okay, general information, things like CPU cycle time, for example, the CPU usage, okay, is identified here. Now we go down a little bit further, and this is a really, really cool part of the system that I like, is actually the wiring diagram. We get calls all the time. Hey, how do you wire this? They say, what do I connect? And I said, well, it's an input device, log device, output device. Yeah, but how do you connect it? When you set it up in the software here and you do the drag and drop like you see and run the report, you get an automatic wiring diagram. That's awesome. So you don't have to, break out a pen and paper and draw up your wiring diagram. It's already in here, and you can export this and put it into your master wiring diagram. Okay, so those are on the inputs, right? Okay, my test pulses. Okay, it shows my emergency stop and also my reset switch. And on the output, I show my contactors. Okay, so again, as you go through the whole report, it shows all the details or anything we configured. And again, we did something very simple. Just wired up an e-stop to actuate a safety function, and we had the contactors to actually do something. The logic device makes a decision, and the contactors actually remove the energy. Okay, now if we had additional things like I/O, okay, this does have the ability to have expanded I/O. Again, we mentioned there were 20 I/O points resident on the controller itself. But if you needed more than 20, okay, we have additional safety inputs. We have additional safety outputs. You also can attach through the backplane on the DIN rail itself non-safety I/O. Okay, things like the lights that are on here, okay, those aren't really safety functions, but we do need I/O points to actually run those.
Is that what the gray module is?
That's exactly what that is. Yes, okay. Absolutely. Good call. And again, it's there's not really a standard that says that they shall be yellow, but it's kind of an industry convention.
Yeah.
Okay, there's a difference between a standard and a convention, and yellow kind of calls out as a safety device, and non-yellow, for example, would be a non-safety, and that is a non-safety function. So again, we have additional I/O not only for the safety but non-safety. And again, people tend to think that the safety itself can't do standard operations and standard logic. But I might point out here in the function blocks themselves, okay, we actually have capabilities like that, okay? In the software itself, okay, you take a peek here, these are just standard logic symbols, right? Okay, I have a not, and, or. I mean, I can do a lot of features on here and really create elaborate safety systems. And again, a safety controller can do some non-safety functions. You just can't go the other way around. A non-safety controller cannot be utilized for safety. Okay, but that's all built into the software right there. And again, if we wanted EtherCAT, for example, okay, EtherCAT was not resident on here. We would add a separate COM gateway to that system right there, and it would show up in our report here. Additional gateways, extension modules, and any sort of logic that we had associated with the system itself. But Again, this report just gets printed up automatically. It shows basically what we saw in the software. That's resident in here too. If you have to go back and make modifications, you're obviously going to change the CRC number, because every time you change configuration, you get a new configuration code. But you do get a chance to basically see, and it's a copy of whatever that you had configured there in the report. So you have the report, you have the modules, and then you have your workspace. And again, all of this was done virtually. All we had was the free software downloaded, and we ran it to run this system for us.
I should have asked you before you close the report. Do you get a bill of materials, like the actual part numbers you need to order?
Yes, absolutely. I'm glad you asked that. Okay, run the report, open it up again, and our bill of material.
That's usually a pretty big one too, because, you're not going to be an expert like they are on their products. They're using their tool to help you select which products you need, especially since you just went through and configured it all. And so there it is. There's your bill of material.
That's the bill of material there. Okay, we have the controller itself. The card is an SD card. Okay,
good point. We should mention this.
Yep. The SD card itself, okay, is specially configured to work with the this. It's not entirely big. It's only a 512 megabyte, but it is required, and this is where all of the safety programs are actually resident. The nice thing about that is if you have multiple safety controllers in your facility and you have your recipes resident on the card here, you literally can take this out and pollinate, literally go to each controller, install it, and then load up and have safety programs. So you go from one controller to the other, but the recipes are resident on the card itself.
So how about duplicating the program? If I'm an OEM and I have a bunch of machines, right? And I just want to duplicate the program, can I use the card to do that as well, from machine to machine?
Absolutely. You could do it card to card, or if you did, use your laptop, okay, and you have the program on there.
Okay, you save right to the card?
You save it to the card. Yep.
Okay. Without having the controller here, you can save right to the card.
Save it right to the card.
Oh, that's a nice feature.
Yeah.
Some people can't do that.
Yeah.
I won't mention any names.
So, yeah, like I say, the good news is it does save to the card. The bad news is you have to have the card as part of it.
It needs to be the company. It needs to be a Wieland card that's matched for that device.
Exactly.
And it's called it out. Yeah, it calls it out.
And then again, the rest of the bill of materials is we have the e-stop, the dual channel closer. That's just the software's name for the reset switch, and a set of contactors inside. But that is, to answer your question, that is the bill of material there. Did you have any questions?
Well, he gave me some of the most popular. I purposely, as you guys know, I purposely don't look at the companies the first time I see them, because I want to try to have a natural reaction like you will the first time you watch this episode.
Yeah.
So in any case, Mike was kind enough to give me some of the questions that come in. So how about number one? All right. So I'm going to read number one here. What makes the Samos Pro Compact ideal for space constraint applications?
That's a great question. And we touched upon this, and it has to do with the actual size of it, okay? As I mentioned, it only occupies 45 millimeters on a DIN rail, okay? And itself is set up with 20 input points, meaning it's 10 safety devices. And let's say I had discrete relays. Discrete relays typically take up 22.5 millimeters a piece on the DIN rail space. 22.5 millimeters times 10 devices, okay, would occupy the whole DIN rail here, okay, for 10 devices using discrete relays. The beauty and the benefit of having a compact like this, it only occupies 45 millimeters, okay? So you have all this additional space for either expansion modules or other products. For example, the controls themselves. Okay, no one says you have to run the controls, okay, for safety in a separate cabinet. They oftentimes share the same space in the cabinet. Cabinet space is valuable. Real estate is very valuable. So again, it only occupies 45 millimeters. It saves an awful lot of space, holds a lot of devices just by itself. So there's an advantage right there. It makes it a quick and easy configuration.
Now, you talked about something. I always thought this was a little odd. So you have an existing PLC, and then the word comes in that whatever equipment you're adding to the line, or maybe it's been reconfigured, and you need to add a safety PLC. A lot of times companies will not. They're like, we're not going to mess with the part that works. We're going to add in a separate safety PLC. And I think that's unintuitive for people who, if you're designing a brand new system, you're going to want to buy a PLC that's a standard PLC and a safety PLC all in one. But I don't think that's That's the opera. Can you just share some of your thoughts on applications that you've seen over the years where they had an existing control system, but they needed to add a safety PLC, and that's where they chose your product because it had to be totally separate from the existing system?
Exactly, exactly. It's often nice to work on projects where you're in the design, the front end, okay, and you can have it all integrated and it all works quite nicely.
Yeah, whatever you want.
But the reality is that we're called upon to add safety to a lot of older legacy systems, and the concept that we always adhere to is really it's a safety layer. Okay.
Yeah.
And I really try in my classes, I try to separate control circuits from safety circuits. I call the control circuits the black circuits, and I call the safety circuits the red circuits. And the red circuits always have priority, okay? And they have overreach, let's say, of the black circuits to remove energy in an emergency situation. I mean, that's what we're here to do, right? We're here, this logic device is here to make a decision on an input. It could be either a detection of a hand or a door opening or whatnot, or in the case of motion, an encoder signal, okay? Identifying overspeed, going the wrong direction, has not reached a 0 RPM state, okay? That's a dangerous situation, and it won't open a door, it won't unlock something until it achieves that state. So to your question, we do a lot of applications where we have to put safety on as an afterthought.
Yeah.
Okay. And we work again with the controls, but we never integrate the safety directly. It always has a priority over it. And the idea is that the safety system will remove the energy from whatever source. And when I say energy, it doesn't have to be just electricity, right? There could be kinetic energy. Okay. There could be hydraulic energy. Okay. Their fluid power safety is just as important as electrical power safety. Okay. Quite honestly.
Yeah.
So those have a priority. It removes that energy from the source, and then it turns around and informs the control circuits. Okay, and this again, it's a little more painful and a little more complicated sometimes to add it onto a legacy equipment, but it does get added all the time.
Yeah, and I know a lot of the vendors these days are only supporting the last maybe the 6 or 7 years of software. If you have a multi-million-dollar system that's full of racks of standard controls, upgrading that, just even upgrading the CPU to get a safety CPU could be more than this entire project.
Yeah.
And I think that's what I've seen is, they don't want to update the software. They don't have to buy new laptops. They don't want to have to stock new spares. That control system is standalone and works great. And so whether they go with the same company or a different company or Wieland, they'll add in the safety, the PLC as a secondary PLC that controls the safety, that's integrated with the safety, because that big expensive system, they can't touch it and they can't afford to upgrade it. It just as a standalone, trying to upgrade that would be really overkill. So, and that's what I've seen. And you guys let us know in the comments what you've seen. Now, am I way off? Let us know in the comments, and I'd love to hear what your thoughts are. But let me pitch it back to you, Mike, and after that interruption, sorry.
No problem. Any other questions by chance?
Hey, I have another often asked question. How does Samos Pro Compact reduce programming and commissioning time? How does it do that?
Well, let's start off with everybody's favorite word. It's free. The software's free. Okay,
yeah, true.
Easy to download, and as we just showed, it's easy to configure. And quite honestly, the complaints for a lot of system setups and a lot of software packages is the complexity of using it. And slowly but surely, software is evolving to the point where it's very graphical and it's all drag and drop. Okay.
Yeah.
And as you saw in the library, all the ingredients are there. Okay. And even if you select the wrong thing and you drag and drop, the output of one thing into the input of another thing. And if it bounces and it won't accept it, you're violating, you're not setting it up properly. So slowly but surely, it'll explain to you. And what you can do in the software too, if you ever have any questions, I should have mentioned this when we were looking at the software, was you can right click on any of the modules themselves and it automatically goes to a help screen and you get all the details on that device, and if there are variables available to change the features on that. For example, like an OR device, okay, or an AND gate, okay, you can pull it up, drag it into the screen, and say, well, it'll default to 2. And it says, well, I need 3. I have 3. Okay, I need this and this and this. Okay, you right click and you have a variable and a drop down, and you can add another input to that.
Oh, that's cool.
Okay.
And I love how you've combined the configurator with the programmer.
Yeah.
So now it's all in one. So you get your bill of materials. You also get to test the program. You get the simulator built in. Very cool.
That's right. And to cut down on commissioning time, again, a lot of this work can be done prior to actually receiving. So you have a concept, a safety concept. You do a risk assessment. You say, okay, I need the following input devices. I need this logic device. I'm going to attach to these output devices. And there's time for that to come in, okay? And you don't have to wait for those to come in, okay? You can actually get the software, start putting all those pieces together and setting up the system prior to the hardware actually arriving. So your commissioning time, you don't start your commissioning time when the hardware shows up. You're literally done before the hardware is done. It comes in.
That's awesome.
Yep. Any other questions, Shawn?
Hey, I got another one right here. How easy is it to connect Samos Pro Compact to existing control systems? I think we know the answer to this one. Go ahead.
Gateways. And again, what we don't have resident on board, the Samos Pro Compact itself, we have additional gateways, okay? CAN open. We have EtherCAT. That's quite a popular gatewaying protocol these days. We're able to add an additional card to that and have that compatibility. And as you saw on the software, it showed up, okay? When you add the cards, the card shows up and that protocol shows up. So it's ready as an EtherCAT module in an EtherCAT based system.
Now, you said that it has Profinet, Ethernet IP, and Modbus TCP built in, which I think is so cool.
Yes.
I'm such a fan of companies that are doing that. But do you have to do something in the software to tell it which one you want to use?
No, you do not. In the software itself, it does, especially when you're using the virtual system, it does a detection, felt detection. Yes. Actually, that's how it works. And then again, you can go in and make a slight or small adjustments. You can actually get addresses through the software itself. So
nice.
it's not, you're not programming, you're configuring.
That's awesome.
It's a huge time savings, quite honestly.
That's awesome. You want me to go to number 4?
Sure, please.
Let me ask you this. Is it suitable for safety critical applications in demanding environments? So yeah, we haven't talked about that yet.
Yes, the device itself typically has most electrical devices in the industry typically have an IP20 rating themselves.
Yeah.
So IP20 doesn't keep out a lot of moisture itself, and quite honestly, these are typically put in cabinets themselves to protect them.
Yeah.
Okay, but the cabinets themselves can experience a lot of temperature variations. Okay, so these are rated between minus 25 C to plus 65 C. Okay, so again, they are designed for harsh cabinet temperatures. Let's say vibration. There are some values of its shock resistance. Okay, I had a customer the other day saying that he was concerned about the vibration that the cabinet was going to receive in a punch press. Every time the punch press, there was just this huge vibration. And we talked about the shock resistance of the controller itself and mounting techniques. I mean, in my job as a safety consultant, as I mentioned, I look at things holistically. I talk about things that, again, things like a shock mounting. Okay, we have the safety light curtains mounted here. At the moment, I have some standard T-fittings, okay, on the brackets, your standard ones. But if I was in a shock environment, I would, talk with the customer and I would say, you know what, based on what I'm seeing here, these obviously will handle a certain amount of shock by themselves. There's no moving parts, okay, so it does withstand a certain amount of shock, but light curtains are notorious for going out of alignment. And over a long distance, if the transmitter is poorly aligned with the receiver, okay, and there's some shock, then they're going to lose alignment with those vibrations, and you're going to have nuisance trips.
Nuisance tripping it.
In that situation, I would tell people, it says, look, we have isolation dampeners, okay, and little rubber grommets that you can actually put between the hardware and give a little bit of a shock resistance to the light curtain themselves to help maintain. these are the kind of little advice nuggets that we deliver when we talk about a system, a holistically system, because we understand, like you said, some of these environments are pretty harsh and demanding. And the controller, as we mentioned earlier too, is a PLE. So the controller itself will never be, the weak link in a safety system. There are some other devices. For example, in the motion world, when we use a Samos motion and we use the TUV function blocks for motion themselves, in addition to those is a vibration toolbox in the software itself, okay? And that helps fine-tune and take out nuisance vibrations that you're trying to detect pulses from an encoder. You're not trying to detect other vibrations, okay? Now, the good news is that you can invoke these things in harsh environments, okay? You will knock down, okay, according to standards, you do knock down your PLE to PLD, but PLD is still quite impressive and robust. And again, the controller tends not to be the weakest link in a safety system. But great question.
Yeah, I'm just seeing something else here too. What are the 4 amps for? Is that each output's 4 amps or?
No, it's the high switching power. That way you don't have to use actuators, okay? You're able to have that. So, again, they tend to be kind of high power on the output side of things, and it reduces the need for additional relays or any sort of additional devices for that.
Yeah. How about question number 5? You ready for that one?
Sure thing.
Encoder types. Does it have to be a Wieland encoder?
I get that all the time. Actually, no. Okay.
Yeah.
It's just looking for a standard HTL incremental encoder. In fact, people are using non-safety encoders too. Okay. There are safety rated encoders and non-safety rated encoders, and they can use it. The good news is you can use a non-safety encoder with it. The bad news is it does degrade the PL level. Okay. You can get PL level E by using safety rated encoders. Again, redundant. You can do 2 tracks, you do 4 tracks, however you need. And again, I gave the example about shaft shearing and trying to detect whether or not you have a broken shaft. If you mount an encoder on both ends and match and tune up those 2 signals together, as soon as you have a deviation, you know you have a shaft breakage. I think we were pretty successful in showing not only the fact that it saves a lot of space on the DIN rail for the number of devices it's able to manage. Okay, the input devices again can be varied. Some of them are here, some of them are not here, but a lot of typical devices that get applied. And again, it's not brand specific. Okay, it's quite agnostic. Okay, most of the safety devices in the industry work with our controller. As I mentioned, the Wieland safety controller is our own product. Okay, so it's our own design, hardware, and both software. So when we have upgrades and development, again, the upgrades are free. Okay, we send out, and anytime the software gets upgraded, there's a point release, whatnot. Those are free. Okay, and we know a lot of people in the industry charge for software. There's licensing fees and whatnot, and that never happens with the Wieland controller products.
Yeah, could you wake up the HMI? It looked like the screen was very well designed. Would you mind tapping the HMI? Yeah, so the HMI is good. So let's talk a little bit about, aside from this, what other products do you make? I mean, you make a safety PLC. It looks like you also make an HMI.
Yes, I'm glad you asked that. By the way, some of the non-safety type products are actually on here. As you mentioned, the HMI itself, okay? It's a touchscreen. And we have various sizes on it. And what you're seeing here on this demo is a representation of a CNC machine. Okay, it gives a little bit of a story behind the devices that go into this. So, for example, I turn it on, I'm running it. Okay, do you hear my CNC running?
Yeah, oh yeah.
There we go. Very robust CNC. Now I go to open one of the doors. Okay. Not only will it stop the motion, but it'll also show me on the HMI which particular door I opened up. Okay, did you see that?
Yeah.
Yeah, that moved. Okay, and back like that.
You see HMI updating as well.
That's right. So the HMI updates itself, and again, it continues to tell the situation. And that's what's nice about sending the output of this over this Ethernet port here to the HMI itself, that when you have a trip, okay, look, I have several safety devices here. I have light curtains. I have 3 door switches here. I have an analog position switch, a distance switch here. I also have an e-stop here. various devices. If I have a trip, okay, and if this was a real machine in a facility, I'd have a light stack and I'd have a light flashing, and you would come up to the machine saying, which device tripped? I don't know. You can look at the HMI and either have a graphical display of the machine itself or a table, okay? It would show all the devices and it would have an indicator of which one it is. So you'd come to the machine, you say, oh, I see what it was. It was that door switch. I close the door and then I have to reset it, okay? A safety system requires a manual reset. You just don't close the door and the machine starts up automatically like that. Okay, and then I did a reset, and then I also did a machine start. And my CNC is back up and running.
That's excellent. That's excellent. So you're more than just safety PLCs.
That's right.
Nice.
We do the safety PLCs, we do the light curtains, we do all these door switches. We have 3 grades of door switches here. The simplest technology, the standard key door interlock, okay? And a standard fork key interlock. The switch goes on the frame, the key goes on the door, open the door, key comes out, and it indicates to the system that there's an intrusion. Now, in addition to that, those are contact switches, okay? We have this version here, and we have a secondary version that's a little bit bigger that has a solenoid in it, and those are locking, guard locking.
Yeah.
Okay? Therefore, if I have an application where I want to go into the cell, but the cell presents a hazard, and the hazard has to either cool off or there has to be a coast down period, say 60 seconds or whatnot, a timer is used inside the controller, and once 60 seconds elapse, it sends a signal to the solenoid to release the door lock and allow you to go into the cell. Okay? And then there's other applications where non-contact is preferred. And we have 2 versions of non-contact here. Okay? One is a coded magnetic. Okay? There are several codes available, and so you can't take another magnet and fake it out.
Big thing, right? It has to be coded. Yeah.
Bypassing.
Yeah.
Bad word in the safety world. I get calls, people say, hey, I have door interlocks. I keep finding the keys in there, but they're not attached to the door anymore. And I said, okay, and we can improve the robustness of the safety system by switching out keyed interlocks to a coded magnetic switch. And these coded magnetic switches do not work with refrigerator magnets, okay? It takes a coded actuator to actually close this. But people that have a lot of these can find another matching actuator and fake these out. And we'll get a call, Mike, I'm getting my magnetic switches being bypassed. What can we do? The next level of technology up is the RFID.
Oh,
okay. RFID is high coded, okay? And if high coded means that you have 1,000 or more codes. And if you have 1,000 more codes, nobody is going to find another matching actuator to fake out the switch and try to bypass it.
When you buy it, do you get it just random from the shelf, or
you get it initially random, and then there's a sequence where you cycle the power to do and change the codes.
Oh, okay.
So you can actually get multiple codes. Okay.
Okay.
Out of that. And again, so we start out with the basic technology. The next step up is magnetic, and the highest level technology is RFID for door switches. Okay. So, and let me see. Now, in addition to all of this, okay, you're going to notice that I have
turn the speed down. So,
I
went back.
Sorry, reverse the direction. That's okay. Or we could have just put our hand in the light curtain or whatnot.
Oh, yeah.
Okay. But in addition to the products, the safety products and the HMIs, we sell power supplies.
Okay.
Okay, so yeah, we have our own power supplies, as a matter of fact. I always advocate people that when they have a safety system is to have a dedicated power supply.
Yes.
They're not really expensive, and for the peace of mind, okay, and for the robustness and integrity of the safety system is to have a separate power supply running the safety system alone, as opposed to sharing it from some other things, okay?
Yeah.
You don't have to worry about spikes in the system. You don't have to worry about inrush currents and whatnot. Again, it's dedicated and it won't interfere with the functions of the safety because, let's face it, you're trying to maintain, say, PLD or PLE safety system. And the best thing that you could do is make the power supply independent, okay? It makes the safety system robust and safer, okay? You always have an eye towards making the application as safe as possible. Now, in addition to the HMIs, the power supplies in here, just within the system here, some of the other products that Wieland offers are distributed power systems, okay? And as I mentioned in the beginning, Wieland is famous for their terminal blocks.
Yes.
Okay? And again, our catalog is full of industrial automation pieces. We really try to bridge from device to device in the automation world all these filler and detail type products, gateway switches. We have managed and unmanaged switches too, by the way. Okay.
Oh, all right. I didn't know that. Yeah.
Yep.
So you have switches as well. Oh.
We do. We do. I invite you to take a look at our website, Wieland-electric.com, and it has a lot of good information, and you'll see the full catalog of information. Today, really, we were just kind of covering safety, but it's really the tip of the iceberg of the Wieland portfolio.
Yeah, and we will conclude not only an end of show slide here so you can see all the important stuff, we'll also include all these links in the description. So wherever you're watching, you'll have links to everything we're talking about, so you don't have to go and hunt it down and like, how do I spell Wieland? And all the links are there. We'll put the slide up on the screen as well, so you guys can see all that good information. And Mike, with that, was there anything else we wanted to cover today?
I think we covered it pretty thoroughly. I wanted to make sure that I showed you the software because, a lot of manufacturers create the box and the little safety PLC. And quite honestly, the magic of the PLC itself isn't the hardware, isn't the 45 millimeters resin case itself. It's the actual software. How easy to use, how comprehensive it is, what information it'll do for you, okay? And again, we showed that we have a workspace, drag and drop, library, pull the devices in. We have motion, we have presses, we have combustion technology, muting. We have a lot of different libraries, function blocks, certified function blocks to drag into the workspace. It creates the report, and basically, again, it just shows you the creation of your system short of hardware. Of course, when you hook up your hardware, you do a synchronization. Okay, and now you can make your tweaks. You may find that your virtual system was better than the hardware list that you created, and you may want to upgrade that at some point. Yeah. Okay, the nice thing about a controller is it's infinitely repurposable. Okay, you program it one way one day, and if you add another device, that's not a problem. It's easy to go in the software and add another device, okay? I subtract a device, change out devices, whatnot. It's easy enough to use. So, yes, again, the Samos controller is a leading product for us in the safety product portfolio for Wieland. And again, we lead off with our software, the Samos Plan software.
Yeah, and I appreciate it. Just that short demo you did really helps. Like, I feel like I could get in there and start doing stuff. When you open something up for the first time, if you've never seen a demo of it, it can be like deer in the headlights type of, and I've been there many times myself. So thank you for not only talking to us about the hardware, talking to us about your company, but also giving us that software demo as well. And I want to thank you for coming out and driving all the way out here, 3 hours to get out here to do an in live. Mike doesn't know this. He's the first one to come and do a live. I had to clean up all last night. The place was so messy, but he was actually the first vendor to come out and do a live. And I really enjoyed having him here, meeting him and the pre-show and whatnot. But I also want to thank Wieland for sponsoring this episode, so there'll be no ads on it. Didn't you guys enjoy having no ads during the episode? We don't make a lot of money from those ads. It's pennies. So thank you please tell your people to thank you very much for sponsoring this episode so we can bring all this information to the audience without any nasty ads. And with that, any final words?
No. Thank you, Shawn, for having me. Appreciate your hospitality, and you did a great cleanup job here. It looks wonderful here, and it's a great format here for us to show off our product here.
Well, thank you, Mike. I hope you come back sometime.
I'm looking forward to it. Thank you.